Hi, I am Sri from Techie Talks AI. Next couple of videos, we are going to focus on Redis. Very often we fail to give attention to Redis or fail to understand how Redis works. So this first video is going to make essential aspects of Redis completely clear to all of you. So stay with me till the end of this video. We will walk you through each command, understand how it works, why it's important for API rate limiting, because we are all SaaS developers, and for SaaS developers, rate limiting and understanding all nuances of rate limiting is critical for our API success. Hi, welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we showcase hands-on demos and insights into AI automation and no-code tools. We have created several make.com modules to simplify no-code automation for you. Subscribe and join us on this journey into the future of technology. So welcome to this Redis deep dive. Today, we are not reading from a textbook. We are learning by doing. This session is a practical command line based execution of Redis, a powerful in-memory data store known for speed, simplicity, and atomic operations. You will be testing everything from basic key value pairs to advanced Lua scripting. Each command demonstrates not only how to use Redis, but why it works the way it does. Our goal is to understand Redis as an active engine, a system that makes instant, reliable decisions. By the end, you will know exactly how to validate and trust your Redis configuration using hands-on tests. So let's get started. In order to get into Redis monitor, we will execute docker compose exec redis CLI. So that is what I have done here. If you type quit to come out, I have typed docker compose exec redis-CLI. How it works, because we have a Docker Compose, same Docker Compose that we have seen in our previous video. And in this Docker Compose, we have the Redis service, which is starting a Redis server on port 6379. Okay, so to get in to this Redis monitor, Docker Compose exec redis-CLI. Redis-CLI is the Redis monitor, the command line interface, which will help us talk to the running Redis engine. And I have 3 terminals colored differently, so we know which terminal we are using. Certain concurrent operations we will try from multiple terminals. But otherwise, most of the commands we will stay in this first terminal. We are in this Redis prompt, which is port 6379 of the local host. Now, basic key value commands. Every journey starts with the basics. In Redis, data begins as simple key value pairs. You can store a value using set, retrieve it with get, delete using del, and verify its existence using exists. These commands form the foundation for every other Redis structure you will encounter. Testing them first ensures connection and container are working properly. When you see instant responses, you are witnessing Redis in-memory speed, no disk latency, no blocking. It is the heartbeat of every more complex feature that follows. So let's try these 4 commands. Set greeting. If you look at the keys, you will notice that there is one greeting key with a value. So if I want to see the greeting, get greeting, the value hello Redis came back. And if you type exists greeting, it says 1. Let's delete greeting. And if you check exists, notice that it returned 0 for false. That means there is no key called greeting. So we have set the key value pair. We saw how to get the value back, and we saw how to delete, and we also saw how to check if the key is present or not. Okay, that is the first thing. Next is atomic counters. So these are operations which will increment a value. And if you have studied database, you will know how complicated it is. These databases are accessed by multiple processes. in order to increment, you need to first read the value, then add 1 to it and write it back, right? So if there are multiple threads reading the value, trying to increment and write them back, there can be missed increments. Whereas in case of Redis, this will not happen. So counters are the first place where Redis atomic behavior shines. Commands like incr, increment, increment by, and decr, decrement, modify numbers safely even under extreme concurrency. Imagine hundreds of users hitting the like or a post at the same time. Redis guarantees every increment is processed sequentially without conflicts. You can test this by incrementing the same key from multiple terminals and verifying that no counts are skipped. This atomic guarantee removes race conditions entirely. It's why Redis counters are used in analytics, inventory tracking, and distributed rate limiting systems, which we will see in subsequent videos. Okay, so first, let's see if there is no page views key. So let's set page views to say 100. And if you get it, you will get 100 back. Now let's increment incr. It became 101. See? And incr by, and if you increment by 5, it became 106. See this? And in the same way, we have decrement. decr, decrement, it became 105. So simple commands, but the significance is these commands can be concurrently executed from multiple threads. Still, it will not miss a single increment or a decrement. I'm now running this from multiple terminals because those are slow operations. Next is another fantastic operation called time to live. This makes data ephemeral. Redis can automatically delete keys after a set duration using TTL, time to live. You can apply it by running expire, the name of the key and the number of seconds. To remove a key after 10 seconds, you type expire, key name 10. Or to create it instantly, we can use setx command. So a key, value and the expiry can be specified in a single command. And there is a TTL command which lets it check how many seconds are left, and when it becomes -2, key is gone. This feature is essential for caches, sessions and expiring tokens. Instead of building cleanup jobs, Redis handles the expiry natively, keeping your memory footprint lean and self-maintaining. So let's see how it works. First, we will create a temp key with a value expire soon, and we will get the temp key okay, and it has the value expire soon. If you keep on checking, value is still there. Let's execute the command from another terminal. Expire temp key in 5 seconds. Let's see. See, it has gone in 5 seconds. Let's set the key again and let's make it expire in 20 seconds. Now, if you see the key is there, if you execute the command TTL, you will notice that it has 8 seconds left, 5 seconds left, 3 seconds left, 1 second, -2, and the key is gone. So Redis lets us set the key value pair with an expiry time. And after the time is over, Redis deletes the key. That is expiry, TTL, time to live. Next is lists. Lists transform Redis from a static store into dynamic queue manager. Using lpush, you can insert new tasks at the head of the list. lrange shows its contents rpop or lpop remove items from either end. We will see that. The combination you choose defines the behavior. lpush plus rpop will give you FIFO queue, that is first in first out queue. lpush and lpop will give LIFO queue, last in first out queue. Test both patterns and see how items move through the list. Lists are the backbone for task queues, job schedulers, and chat message buffers. Fast, lightweight, and endlessly flexible. Let's try the command. First item is pushed in. Second item is pushed in. And if you want to see this, see the list, tasks, this is the way. See, first item is pushed down. Clear? Now we will do rpop. rpop tasks. So which item will go out of these? Task 1 will go or task 2 will go? rpop removed task 1. Okay. So if you look at this, we have task 2 in the list. So in the same way, we have lpop, which will remove the first item in the list. Easy to remember, first item is seen as left. Last item is seen as right. Okay, next is sets. Unique collection, where there cannot be multiple keys. These are also key value pairs. Sets ensure uniqueness automatically. When you add elements using sadd, Redis ignores duplicates silently. Try adding the same member multiple times and the count is returned by scard, and that never changes. Retrieve all items with S members or test membership S is member. Sets are perfect for tracking unique users, tags, or IP addresses without duplicates. Their built-in mathematical operations like unions and intersections make analytics a breeze. Let's try it. sadd users 3. Return 1 means it was successful. sadd users RB. Return 1. That means second item also is added to our set. If you try to add 3 again, it returns false, which means this is a duplicate. Clear? Now, as members, users, it will show the members in the set. Now, S is member, users, and the key. That is true. 3.1 is false. That is true. Clear? So that is about sets. So these are the commands that we saw. sadd will add items to our set. Members will show the members in the set. And scard will show the number of items, 2 items. Okay. Remember, sets are unique. Elements are unique. The key names have to be unique. Another very important, very interesting thing, sorted sets. This is slightly confusing, so stay with me. Sorted sets add a score to each member. That is, each key will have a number also. It will always order the set with that number. So what is the use of that number? When you want to rate limit based on sliding window, which we will see in subsequent videos, this is critical. You add entries using zadd, view item with z range and z range with scores, and remove outdated ones using z remove range by score. That is the most significant command. Z remove range by score. When the score represents timestamps, you can build sliding window logic, ideal for real-time rate limiting or leaderboards. Try adding events with time-based scores and prune anything older than 10 seconds. Redis instantly recalculates what is inside your live window. It is elegant, fast, and foundation for fairness in throttling systems. So let's try it. Okay, 101, we have added 102 and 103. So 3 values we have added with scores 1001, 1002, 1003. Now, in order to see, we need to give with scores. Z range visits with score. See here, 1001, 2, 3. It is ordered. Got it? So if we add another request, say 800 as REQ4, where will it go? See here, it came as the first item. Let's add 8000 as request 5. Where will it go? See, it went at the end. So it will automatically store the items in the order of the numerical score. So next command is remove range by score. So it removed remove range by score 1002. So it removed 1002 and below. Okay, so if you remove range by score 9000, all the items are removed. Okay, hashes. Hashes store mini records. Think of them as lightweight JSON objects. Each hash key contains multiple fields. Use set to create fields like name, plan, or age and retrieve everything using getAll. You can even update numerical fields atomically like inc by. This structure is perfect for user profiles, configuration data, or application sessions. Because everything stays in memory, Redis reads and updates are instantaneous. Hashes keep related attributes organized under one parent key, improving structure without overhead. We have to see it to understand it clearly. Clear the screen. So here, set user colon 100, name Sri, plan gold, age 68. So here what it has done is, this user colon 100 is actually a string, which is the key name. It could have been user 100, it could have been user 1. So don't get confused by seeing this colon here. Treat it as just the name of the key. And key values are name equal to Sri, plan equal to gold, age equal to 68. So that is how it should be read. So this is the parent key, and these are the key value pairs beneath that. So if we type getAll user colon Sri, name, plan, age, everything comes together. If we want to get only one item plan for this user, we can enter plan like this. Increment a value, increment age by 1. See, 68 became 69. Clear? Now let's talk safety. Redis transactions ensure multiple updates succeed together or fail cleanly. You start with watch on specific keys, queue operations with multi, multi, and commit with exec. If another client changes a watched key mid-transaction, Redis aborts it automatically. This optimistic locking model prevents partial updates while maintaining concurrency. We will test it by running 2 clients on the same keys. You will see how one succeeds, and it is lightweight integrity protection for distributed systems. And remember, this demo is very critical. You will not find such a demo anywhere. So let me clear the screen and set stock A. Okay, so if you get stock A, you will get the value. Let's get stock A from another terminal to confirm that the value is there. Okay, we will set stock B value 5. Okay. Now what we need to do is we need to execute watch command. Okay. So on this terminal we executed the watch command, and second terminal also we are executing the watch command. There is no error. And first terminal we will execute multi, no error, multi, new, no error. And here it says, in the prompt it says TX, which means the transaction has been initiated on both the terminals. Remember, we executed watch command for these two variables on both terminals, and we executed multi command on both the terminals, no error. That means we have initiated the transaction on both the terminals. So if there are two different threads, both threads have initiated the transaction. We will decrement stock A by 3. That is 10 should become 7. On the other terminal also we will execute, and both says queued, and we will increment stock B by 3. So 5 should become 8. Here also we will increment stock B by 3. 5 should become 8, or 8 should become 11. Now how will we execute? We execute by exec. We'll keep the exec command ready on both. Let's execute here, and let's execute here. See, it ignored. Whichever terminal or whichever thread executes exec first will commit the queued commands. That is the idea. So now if you look at get stock A is 7. It did not become 4. And stock B is 8. It did not become 11. Clear? So that is the idea. Pipelining and batching. Network latency can slow even fast commands. Pipelining fixes that by grouping many commands into one round trip. You can demonstrate this by queuing multiple set operations in a multi-block, then committing with exec. Follow it up with mget to retrieve them all at once. Without pipelining, each command requires a request response cycle. With it, hundreds can be processed in the time of one. This is crucial for bulk data loading or high throughput caching. Essentially, this is executing multiple commands. I will copy all the commands together and execute. See, multi, set A to 1, set B to 2, set C, queued, and then exec, executed, and mget A, B, C got all the values. Clear? That is it. So essentially multi will begin queuing, then you can add several commands to the queue, then exec to execute it instantly. Next is pub sub real-time messaging. Redis isn't just a store. It can broadcast messages instantly with pub sub. One terminal runs subscribe while other sends. So subscribe alerts, and another one publish alerts. We will see how it works. Subscribe alerts, it is saying reading messages, or control C to quit. Now from another terminal, we will publish a message to alerts. Okay, it was successful. See here, Redis is awesome. Redis is awesome. See, you see any practical use for such a subscribe publish option within Redis? But remember, such queues are important, like AWS simple queue, RabbitMQ, etc. We will make similar videos to cover those aspects as well, because those are all critical for scalable architecture. Next is Lua scripting. Lua scripting lets Redis perform complex logic automatically on the server itself. Like, in databases, we have seen stored procedures, something similar. You can send a mini program using eval, like a wallet debit check, read the balance, compare, decrement, if sufficient, otherwise return an error. The entire script runs as a single uninterruptible operation inside Redis event loop. No race conditions, no partial updates, and fewer network round trips. It's perfect for rate limiting, credit management, or enforcing business rules right where data lives. So let's execute this. Okay. See here, get balance 70. So eval local balance. So initially we are setting balance to 100. Then we are decrementing 30 from it. And if balance is not sufficient, it should return -1. That is the command. So what we will do is, we will not set the value to 100. We will execute the eval and get balance and see what happens. See, it became 40, 70 became 40. Let's execute again. 40 became 10. Let's execute it again. It will not go below that. Clear? So that is Lua scripting. Scan keys exploration. Exploring what is inside Redis safely requires care. The keys star command lists everything, but you can freeze large servers. Instead, always use scan. It iterates gradually, returning batches of keys without blocking others. You can combine it with match pattern to filter like scan 0 match user : star. Test both commands to see the difference in responsiveness. Scan is your friend in production environments where performance matters. So unnecessarily do not execute keys command. This is the keys command. We only have few keys, so we will not see any performance degradation with keys. Scan match star will bring all the items, but it will return only 10 items. So you can decide how many to return, and you can also give a pattern like this. Okay, so it will return items starting with those alphabets. Clear? And there is a command type stock A, or type the key name will return the value string, return the type of the object. Now, monitoring and performance insights. Redis gives you deep visibility into its own behavior. Run info to view the memory usage, connection stats, and command frequencies. Use info command stats to see which operations dominate your workload. For live debugging, monitor streams every command from every client in real time. It is eye-opening to watch your rate limiter keys appear, increment, and expire as you hit endpoints. These tools turn Redis into a transparent system. You can literally watch its heartbeat. So info memory will give, we are not going to look into it. Info stats, again, it will give you its internal statistics, and then command stats will give you the commands, all the commands that we have executed. And then comes the interesting command monitor. So let's run monitor on one terminal. Okay, and execute some commands. Say get stock A. See, monitor will show you the command. If there are no commands, monitor will be pinging to ensure that the server is running. Now, let's try another command. Type stock A. See, type stock A. So all the commands from all the threads or all the terminals will appear real time in the monitor screen. Okay, rate limiting simulation. Let's try these commands. We will execute. Let's clear the screen. Okay, so see, it has gone after 10 seconds. Remember, don't get confused by seeing this colon here. The whole thing is the name of the variable or the key. And the value is 0. 10 is number of seconds for it to live. Okay. Now watch live changes. We saw how we can use monitor to see the live changes. And flush and reset. If you see key star, we have so many variables set or key set. If you type flush all, everything is cleared. Okay. So it is a risky command. But remember, there is a command like that. Flush all. Summary. Just to summarize, increment, decrement for counters. TTL will expire values automatically. Hashes can set multiple values. And sets, Z set will give ordered sets. And Lua using eval. Transactions watch, multi and exec. Publish and subscribe to a message queue. Monitoring, monitor command lets us monitor it live, and info gives us internal state of the Redis engine. So we have just walked through Redis from the ground up, from simple keys to complex atomic scripts. You have seen how every feature can be tested right in the CLI itself. Instant feedback, visible state, and predictable behavior. Redis is more than fast storage. It is an intelligent coordination of layer for modern systems. The best way to master it is to keep experimenting, try variations, cause conflicts, and watch the results. Redis rewards curiosity with clarity and control. And subsequent videos, we will see Python-based rate limiting applications, how we can secure fast API endpoints, essential for SaaS developers. Thank you for your time. Please remember to like, share, and subscribe. Bye-bye. Thanks for watching. Please like, share, and subscribe. Your support really helps. Have ideas or suggestions? Drop them in the comments. Let's build together. At Shogini, we offer expert NoCodeMake.com and Python AI automation consulting with ready-to-use modules to jumpstart your projects. Stay tuned and subscribe for more.